Alright, so this is the math practice that I sent you guys the other day. So we got first question number 1. You are responsible for providing the proper dose of etomidate to your partner so that he can intubate or initiate the RSI procedure for your patient. Patient weighs an estimated 175 pounds. You are to draw up 0.3 milligrams per kilogram of etomidate into the appropriate syringe. How many milligrams are required? How many milliliters? So you need how many milligrams? How many milliliters? How many vials? Work. Alright, so it's a 3-part question. So first things first, you're going to transfer your pounds to kilograms. So that means 2.2 into 175. You're going to move that decimal point over. Move that decimal point over and add your 0. So 22 goes into 175 7 times. 14. Let me drop that down. Goes into 210. Six. 9 times. Goes into 120. Oh, puppy. Still eraser. 5 times. It's 10. 10, 11. Right. So you're going to have a decimal here. But this is an estimated weight, so let's use, for this example, we're going to use just 79. Alright. So your patient is 79 kilograms. That means to get your milligrams, you need to do 79 times 0.03. 27, 21, 23. And then you have to move your decimal point over 1. So you are going to use 23.7 milligrams. Now if you look at the handout, the etomidate comes 20 milligram vial. It is 2 milligrams per milliliter. So you're going to take how many milligrams you need and divide it by your dose on hand. So let's choose color. So you're going to see how many times 2 goes into 23.7. Bring the decimal up. That's where I'm going to go. Add a 0, bring it down. So you are going to need 11.85 milliliters. So if you have a 20 milligram vial, you already know that you are going to need 2 vials. Question number 2. So now your patient is asleep. You give your partner the syringe of succinylcholine that you drew up based on the patient's weight. So the patient's weight was, we said, 79 kilograms. The dose is 1.5 milligrams per kilogram. How many milligrams do you need? So that's your first step, which is going to be multiplying 79 and 1.5 to get your dose, your desired dose. So that's 45, that's 35, 39, that's 9, 7, 18, 11. You have one decimal point, so you're going to move it over 1. So your required dose is 118.5 milligrams. Now, they want to know how many milliliters you're going to draw up. And on the handout, it says that you have a 10 ml vial and you have 20 milligrams per milliliter. So if you multiply how many milliliters you have by how many milligrams is in each milliliter, you get that you have 200 milligrams and 10 ml. So if you know that you have 200 milligrams and you need to draw up 118.5, you're going to cross multiply. So you have 200x equals 1185, because that's 10 times 1, 18.5. So x equals, there's some erasing, x equals, still eraser, 200 into 1185. So 200 goes into 1185 5 times, right? So remember, quarters. So 1,000. This is 185. You can add a 0, bring the decimal up. It goes into this 9 times 0, 0, 8. And add another 0, bring it down. 200 goes into 500 twice. Add another 0. 200 goes into 1,000 5 times. So you are going to draw up 5.925 milliliters. Question number 3. Now it's time for the verocorium to be administered to the previous patient. The dose is 0.01 milligrams per kilogram. The patient is 79 kilograms. How many milligrams are required? How many milliliters would you have in the syringe? And if you look at the picture, you have a 10 ml vial that is 1 milligram per milliliter. So first thing you're going to do is you're going to find out your desired dose. You have 2 decimal points, so you're going to go 1, 2. So your desired dose is 0.79 milligrams. Now, you can look at the vial. It's a 1-for-1, right? So there's 1 milligram and 1 ml, which means that you are going to draw up 0.79 milliliters. That's your other answer. But if you're uncertain as to we got there, have 1 milligram and 1 ml, right? So 0.79 equals 1x, divide by 1 on both sides, it's 0.79. Question number 4. You are going to be initiating a nitroglycerin drip in the field for a patient with a confirmed STEMI. You have your micro drip tubing, and are to start the drip at 15 mics per minute. Patient says he weighs 180 pounds. How many mLs per hour? We're not going to answer that one because that math hurts my head. We're going to find out how many drops a minute. So, first things first. You are going to be putting 100 micro, or you put this entire 250 milliliter vial. If you look at that, it gives you a dosage of 100 micrograms per milliliter. Do you need to know how much the patient weighs? If you look at your desired dose, there's nothing talking about kilograms in it, so no, it doesn't matter how much your patient weighs. So, it's telling you what your desired dose is, which is 15. It's telling you what's in the vial that you're going to hang, which is 100, which is your dose on hand, and it's telling you that you have a micro drip. So if you multiply this out, 15 times 60, 30. 1 times 0 is 0. 1 times 6 is 6. Is 900. Over 100 times 1 is 100. So you are going to give the patient 9 drops a minute. Question number 5. You are responsible for starting the Cardizem drip using micro drip tubing, so 60 drops. For a 200-pound male who has had his heart rate controlled with a bolus of several minutes ago. Protocol states you are to mix 20 milligrams into a 150 milliliter bag of D5W and deliver it at a rate of 5 milligrams an hour. So, if you look at what you have, if you're putting 20 milligrams in, you have a 20 ml, so that the vial that you have is 25 milliliters. There's 5 milligrams in a milliliter. So if you are going to get 20, that means 5 times 4 is 20. So that means you are going to be putting in 4 milliliters into your 150 milliliter bag, which is that first question. How many milliliters must be added to the bag from the vial? It's 4, right? So how many drops a minute are necessary for administration? So you want to give that patient 5 milligrams an hour, so you're going to find out your concentration. So you have 20 milligrams in 150 mLs. You can simplify so that you have 2 milligrams and 15 mLs, which if you then reduce it further, that means that you have go backwards. So you're going to divide this out. 15 goes into 20 once. Make sure you bring that decimal up with a 0 in front. Add another. Fifteen goes into 50. 15 and 15 is 30. And another is 45, so that's 3. And this is a repeating decimal because the number keeps ending up the same, so you have a concentration of 0.13 milligrams per milliliter. This becomes your dose on hand. So, your desired dose is 5 milligrams an hour, so if you do 5 times 60 to get how much per minute, it's 300 nope, just kidding. Did that backwards. You have to divide by 60. So 60 goes into 500. Oh, let's start here. 60 doesn't go into 5. 60 doesn't go into 50. 60 goes into 508 times 8. This is 0. It's 48. We add another 0 and bring it down. 60 goes into 20 3 times. Or 200, sorry. 200 3 times. It's 180. So you see here again we have another repeating decimal because it's still 20. Every time you bring down another 0. So you are going to have your desired dose, which is 0.83, sorry, 0.083 over 0.13 times 60 over 1. This is a messy one, so I do some erasing over here. So you have 0.083 times 60. So it's 1849. And you have 3 spaces after the decimal, so that's 1, 2, 3. 4.98 over 0.13. And I'm going to cheat a little bit. I'm going to use a calculator. 4.98 divided by 0.13 equals 38.3 drops a minute. Now that I'm sure your head hurts, here's question number 6. You are resuscitating a patient who is in cardiac arrest with a V-fib rhythm. You are responsible for all drug administration, so your first priority is a bolus of epinephrine. Now you need to administer 1.5 milligrams per kilogram of lidocaine, because that's the only antiarrhythmic that your service currently stocks. How many milligrams are necessary for a 270-pound patient? You have a pre-filled syringe that has 100 milligrams in 5 ml. So, first thing, we want to convert your 270 to kilograms. So if you divide by 2.2, move that decimal over, So 22 into 27 goes once. 22 into 50 goes twice. 22 into 60 also goes twice. You're going to add that 0. 22 into 160 is 4. Now that doesn't seem right. Hold on. Nope, read my own handwriting wrong. 7. 14. 14, 15. And this looks like it's going to be another one that's not too pretty. Here's 44. So it's 122.72 is your kilograms. So let's round that up to 123 for ease of math, since we've done some pretty enthusiastic math so far. So let's find out our dose on hand, which is times your milligram per kilogram spot right here. So it's 10, 11, 5, 6, it's 2, 2, 1, 3, you have 1 decimal point. So you want 100, your desired dose is 183 milligrams of lidocaine. So if you have one pre-filled 5 ml syringe, you have 100 milligrams, which means that you are going to need 2 vials, or more than, you're going to have 10 mLs, right, for 2 vials, will get you your 183. Now, if you wanted to actually do the math and find out exactly how many milliliters you're going to need, you have 100 in 5 ml. You want 183. 100x equals 83 times 5, 15, 41, 915. Divide 915 by 100, okay, it's 9.15 milliliters. So you're using almost 2 whole syringes. Alright, question beyond. Alright, question number 7. Your patient from above is resuscitated after a couple of rounds of drug therapy, and you now must start a lidocaine drip at 3 milligrams a minute using microdrip tubing. How many drops a minute are necessary? So, if you look at the bag is 4 milligrams per milliliter. So this is your dose on hand. This is your desired dose. Super simple. So you're going to put your desired dose over dose on hand times your microdrip. That's 180 divided by 4. That's 3. Nope, just kidding. That's 4. Brain fart. 16. That's 5. So, your patient needs 45 drops a minute. One wasn't too bad. Question number 8. You have a patient who's presenting with exacerbation of CHF. After the administration of nitro, you decide to give them Lasix at a dose that is twice of their daily dose. Patient normally takes 40 milligrams of Lasix daily. How many milligrams do you give to the patient, and how many mLs will you draw up from the vial? The vial is 10 mLs. It is 10 milligrams per milliliter. So, first things first, if you're going to give the patient twice their daily dose, and their daily dose is 40, you're going to just multiply by 2. So you want to give the patient 80 milligrams of Lasix. So now you look at your vial, and some of you probably already know what the answer is, but you have 10 milligrams per milliliter. You want to give 80 milligrams. How many milliliters? So 10x equals 80. X is 80 divided by 10, which is 8. So you're going to give 8 milliliters of the Lasix. Question number 9. You are treating a patient who has a possible broken hip, and you wish to provide the patient some pain relief. You decided that you should give the patient 75 micrograms of fentanyl, because you are a super nice person. How many milliliters will you deliver from the fentanyl vial that you have, which is 100 micrograms, into mLs? So again, you have your dose on hand, which is 100 over 2, which you could also turn into 50 over 1 ml. And then you're going to cross multiply. 75 micrograms, 100 mLs, so 50x equals 75. Add a decimal, add a 0, 50 goes into 250, 5 times. So you are going to give your patient 1.5 milliliters to get them 75 micrograms. Question number 10. Your patient above is not tolerating the situation very well, so you think that she should just forget the entire ordeal. So you decide to give her 2 milligrams of Versed. You're very, very kind today. How many milliliters would you draw up from a 5 milliliter syringe or vial that is 5 milligrams per ml? So you want 2 milligrams. You want to know how many milliliters. You have 5 milligrams, 1 ml. 2 equals 5x. You divide 2 by 5 to get x by itself. Add a decimal. 5 goes into 20 4 times. So you are going to give that patient 0.4 milliliters of Versed. Question 11. Patients from above starts to break out in hives. If you're having a really rough tour and you want to give them 26 milligrams, which although is not realistic, just makes the math problem, how many milliliters will you deliver from a 50 milligram per ml vial? So you want to give your patient 26 milligrams. You have 50 in 1 ml. 50x. You got to divide 26 by 50 to get x by itself. 50 does not go into 26, so you add your decimal, you add your 0. Just kidding, too much enthusiasm. How many times does 50 go into 260? It's 5 times, 250. Add another 0, drop that down. How many times does 50 go into 100? It goes in twice. So you're going to give that patient 0.52 mLs of Benadryl. Question number 12. Same patient is having a lot of problems today that you think might be associated to Versed, so you tried to reverse the effects by administering some Romazicon. The dose is 0.2 milligrams. How many mLs will you deliver from a 10 ml vial, whose dose is 0.1 milligram per milliliter? This one you could probably do in your head, just based on how easy it is, these two numbers, right? But if you want to give that patient 0.2 milligrams, and you have 0.1 milligram in 1 ml, 0.2 equals 0.1x. Try to get x by itself. That means you are going to divide, which gives you 2 ml. Alright, question 13. Problems are still abounding. Maybe it's a fentanyl. You decide to deliver 0.4 milligrams of Narcan. The vial is 10 mLs, and it comes in a concentration of 0.4 milligrams per milliliter. If I have to do math for this one, y'all are a little bit more lost than I thought. Question 14. You're working with a patient in cardiogenic shock and decide to initiate a dopamine drip at 5 mics per kilogram per minute. You're using a 60 drop set, and the patient weighs 144 pounds. How many drops a minute? Okay, so first things first, let's convert to kilograms. Move your decimal over, move your decimal over. 22 goes into 14. 22 goes into 144 6 times. Drop your 0. 22 goes into 120 5 times. Make that 0 look a little bit better. 5 times, right? So 10, 11. Here's your decimal, add another 0. 22 goes into 100 4 times. And here, if you see this, you got this repeating decimal that's going to keep going. So 65.4. So we'll use 65.5 kilograms. And you're going to multiply it by your desired dose. It's 5. 25, 27, 30, 32. 1 decimal point. So, do some erasing. Your desired dose is 327.5. Your dose on hand, if you look at that picture, is 1600 micrograms times your drip set. So I'm not going to do the long math, totally going to cheat a little bit. So you have 19650 over 1600. You can make it a little smaller. And then divide, and your answer comes to 12.28 drops a minute. So they also wanted you to solve for if you were using 45 drop set tubing. So I was going to change that out here. For 45. So if you do the math, it becomes 14737.5 divided by 1600. And all said and told, that becomes 9.2 drops a minute. Question 15. You are underway on a long transfer and have been ordered to add 1 amp of pheotonin to a 150 milliliter bag of saline to be run over 1 hour. How many drops a minute if you're... So you have a 1 amp of pheotonin, which obviously doesn't matter because you're going to put it in a 150 milliliter bag, and you're going to give that whole bag to that patient using microdrip tubing over 60 minutes. So you have your volume, which is 150, over your time, which is 60 minutes, times your microdrip tubing. So this becomes, these two end up canceling each other out because you're multiplying it on top and then dividing it, comes right back out. So it's 150 drops a minute. Second part of the question asks, what happens if you are using 10 drop? So same thing, volume over time, 50 over 60, and it's an alpha 6 times your drip set is 10, becomes 1500 divided by 60. Make it a little smaller. So 150 divided by 6. 6 goes into 15 twice. 6 goes into 30 5 times. So you are going to have 25 drops a minute if you were using a 10 drop set. Question 16. You're going to start a nitroglycerin drip for your patient, but your partner forgot to restock, so you have to put 30 milligrams into a 100 ml bag using micro drips at 40 mics a minute. How many drops a minute should you use? Because I think that the question asking how many milliliters would you add to the bag, you can add the whole thing. It really doesn't matter how much you add, right? You can make it hard, you can make it easy. But first things first, let's figure out our concentration if we do put 30 into a 100 milliliter bag, right? So you have 30 in 100 milliliters, but you want micrograms, so you're going to move this over. 1, 2, 3. Right, so that's micrograms. Now simplify. So your dose on hand is 300 micrograms per milliliter. Now, if you plug that into your formula, your desired dose is 40 mics. Your dose on hand is 300, and you are using a 60 drop set. So, before you go any further, you can simplify. This becomes 6 times 4 is 240, divided by 30. Again, you can simplify. Now, how many times does 3 go into 24? 8. So you're going to do 8 drops a minute. Oh, I totally missed. I did it backwards. So this is actually question number 16. The last one was question number 17. You were treating a patient who has had severe exposure to organophosphates. Protocol wants you to give 7 milligrams of atropine. You have a vial that has 0.4 milligrams per milliliter, the 20 ml vial. So this is again another, you have 0.4 milligrams in 1 ml. You want to give 7 milligrams to find out. So 0, your x equals 7, x equals 7 divided by 0.4, 0.4 into 7. Move that decimal point over 1, so you're dividing by 4 into 70. 4 goes into 7 once. 4 goes into 30 7 times. And add your decimal point, add your 0, drop that down. 4 goes into 20 5 times. So you are going to give that patient 17.5 milliliters. This is actually 16. This is 17. Small brain fart. Alright. Question number 18. We're almost done. You have a patient who is suffering from severe hypertensive emergency. Medical control orders you to give 20 milligrams of labetalol over 2 minutes via IV push. You are then to administer 2 milligrams a minute to achieve a blood pressure that's reduced by 30% from where it started. You routinely mix your labetalol by adding 100 milligrams into a 150 milliliter bag. And you use a 45 drop set. How many mLs or how many drops a minute do you need to do? How many milliliters do you need for the original IV push order, and then how many drops per minute do you need for the second? So if you have the vial that's here is a 20 ml vial that is 5 milligrams per milliliter, you need to give 20 milligrams, so that's 4 mLs. Alright, we did that math a little bit earlier. So now you're going to find out your concentration. Right, so you've put 100 milligrams in 150 mLs. So you have 100 over 150. You're going to simplify, and then you're going to divide, and I'm going to tell you it's 0.66 milligrams per milliliter. So now your desired dose is 2 milligrams. You have 0.66 is your dose on hand. And, oh, wrong one. And you are going to use a 45 drop set. So 2 times 45 is 90 divided by 0.66. So we move the decimal point over 2, move this decimal point over 2. So now it becomes, let's just clean this up a little bit. So after you move your decimal points, it becomes 66 into 9,000. And I don't know about you, but I'm going to use my calculator. Divided by 66 comes to 136.36 repeating. So you're going to give that patient 136 drops a minute. Yeah, this isn't pretty math. Alright, you have a patient who needs 20 milligrams of Toradol. You have a vial that is 60 milligrams in 2 mLs, which is 30 milligrams in 1 ml. You want to give 20 milligrams, 30x equals 20, x equals 20 divided by 30. You have to move that decimal point over, bring that up. 30 goes into 20, or 200, sorry, 6 times. It's 180 times 20, add another 0, so you can already see this is going to be a repeating decimal. So you are going to give your patient 0.66 mLs of Toradol. Last one. You have a patient in SVT refractory to adenosine. You decide to administer 0.25 milligrams per kilogram of Cardizem. Patient weighs 145 pounds. How many mLs will you draw up from a vial that is 5 milligrams per milliliter? So first things first, right? Convert this. So 145. I'm just going to give you the number that we're going to use. It is 66 because it comes out to 65.9. So we'll round that up to 66. Maybe they had a big lunch. So you're going to multiply that by 0.25. And that gives you 16.5 milligrams as your desired dose. So now, to find out how many milliliters, you have 5 milligrams in 1 ml. You want to give 16.5 over x. 5x equals 16.5. Divide 16.5 by 5 to get the x all alone, and that is 3.3 milliliters. And that's it. Hope that helped.